Hello, I'm Jennifer, the artificial intelligence digital operator from Geos Technologies. I'm here to introduce you today to the future of energy, which is heat transfer from exogeothermal hot, dry rock. What if I told you that there is a virtually limitless, clean, reliable, and sustainable source of renewable energy that is available 24/7 all over the world, and that it could provide all the energy we'll ever need for the next 2 million years without hurting the environment or depleting? Geothermal energy is one of the most promising sources of renewable energy, and it's also one of the most underutilized. This energy solution simply works by capturing heat from the Earth's core and moving it to the surface, where it will be converted into heating, cooling, or electricity. For the last case, the geothermal power plants work similarly to thermal or nuclear power plants in that they use hot pressurized steam to power a turbine that drives a generator, instead of burning fossil fuels or create fission to release energy and generate hot steam. Geothermal energy directly uses heat from the Earth's core as a primary power source. I'm sure you're probably asking yourself, how much energy can be extracted this way, or how much is available down there? Are we going to cool down the Earth and destroy our planet if we use geothermal power plants all over the world? All right, to begin with, our Earth's solid core is at a scorching 6,000 degrees Celsius. The Earth, since it's been around, has had lots of radioactive isotopes that mainly contribute to the Earth's crust heat. This heat is coming from physical elements present at the lower layers that are simply decaying, and when these radioactive elements impair, they produce something called decay heat. This process is categorized as exothermic, which means that it basically releases heat instead of taking heat. The radiogenic decay heat is very powerful, and the subsurface elements alone make up for about half the power the Earth is giving off, and on top of that, they have a very extremely long lives. The heat generated through radiogenic decay of the main elements is conducted from the lower core to the outer layers through the rock, creating an unlinear temperature gradient that extends from the core to the Earth's crust, where we can tap into this heat. All over the world, and based on the geology, we notice that at only 4 or 5 kilometers, we will find an average temperature of about 230 degrees, when in some other part of the world, the average temperature can reach up to 350 degrees, with gradients that can exceed 130 degrees per kilometers. To simplify all these terms, the geothermal energy is, for all practical purposes, available quite everywhere as hot, dry rock resource, and it is an inexhaustible resource that can provide clean and carbon-free energy in a very reliable and predictable way all around the clock, making it one of the few available options to replace nuclear, gas, or diesel turbines for baseload power generation. At this day, geothermal solutions are divided into two categories, which is mass transfer or heat transfer. The global worldwide capacity is right now dominated by mass transfer that is based on visual detection of faults to produce energy. The geothermal power capacity produced by mass transfer worldwide reached an amount of 15.6 gigawatts in 2021, which is roughly 0.6% of our current power consumption. Mass transfer technologies are mainly using reservoir steam to power electrical generators. This solution comes in several variations, where the most common are dry steam, flash, and binary geothermal power plants. And now, let's dive in and introduce you quickly to these technologies. Let's start with dry steam geothermal. This setup feeds hot water vapor and steam extracted from hot underground permeable reservoirs directly into the turbine. The steam is then cooled, condensed, and pumped back into the reservoir as liquid water through the injection well. Dry steam power plants. In opposition to dry steam, we will find flash geothermal power plants who extract high-pressure, high-temperature liquid water from the production wells into a flash tank where it evaporates. This process will produce a high-pressure steam that is then fed into the turbine. Finally, and to complete the cycle, we will have binary cycle power plants that use one fluid, which is usually liquid water, to extract heat from the permeable reservoir and right away transfer that heat through an exchanger to a working fluid. Usually an organic compound with a much lower boiling point will readily evaporate, producing the steam that is used to power the turbine. Binary plants are great as they can work at much lower temperatures and therefore at much shallower depths than dry steam and flash power plants. All these presented technologies are highly mature, on the shelf, and have already been deployed at commercial scale worldwide. The other technologies that emerged to replace the natural hydrothermal power plants is the EGS, which is an enhanced geothermal power plant that artificially creates the much-needed porosity within the earth by injecting fluids as water and allow it to flow from an injection to the production well. This process is done by pumping cold water into the hot solid rock, causing the rock to crack because of thermal contraction and water vapor pressure. But as you can imagine, mass transfer geothermal solution is not that perfect, and it comes with some drawbacks, which are mainly related to the early site detection and deployment. The actual method of exploration required geologists to locate and find suitable site based on visual exploration and detection of faults. Once selected, they will need to ensure that the site is suitable and include the perfect combination of heat, fluids through the faults, regeneration capacity, steam, water, and most importantly, fractured and permeable rock. All these elements will need to be combined in a perfect way that allow a natural exploitation of the site. In case of dry wells, the enhanced geothermal solution is applied to replace the water and fault fracture if the rock is not enough. But the risk lies in the seismic activities as we inject cold water into a hot, dry rock. The subsurface rock sees this pressure change and they increase the risk of earthquake. The exploration to find the combination of these perfect elements can take years and a large amount of capital, with risks that sometimes are never recovered. Today, new technologies exist and are more appealing and economically viable and feasible compared to the previous and complex hydrothermal solution. The heat transfer solution, which is a geothermal with a closed and sealed pipe that replaces the hydrothermal or EGS solution by removing and eliminating the need for fractured rock, faults, or even steam in reservoir. This technology, named AGS, is mainly targeting the heat located in the hot, dry rock that comes from the radiogenic radioactive decay. A closed-loop heat exchanger is sent at lower ground to capture and transfer the heat from the subsurface to the turbine with a high efficiency and no loss. This new technology is named AGS, Advanced Geothermal Solution, and it represents the future of geothermal, as it directly targets the hot, dry rock, which represent 98% of the geothermal resource available over the world, compared to the limited natural hydrothermal resource that represent only 2%. With the AGS, there is no fluid exchange with the subsurface, as no water is injected into the rock, so the pressure doesn't change. In the meantime, by using AGS, the heat extraction from the underground is more efficient and clean compared to EGS, as there is no underground water pollution and there is no brine, carbon dioxide, sulfur, or other type of emissions. It is important to note that technology evolved very fast, and today there is even more newer technologies than AGS. These new technologies are not only baseload, scalable and dispatchable, but also able to address one of the most complex issues that geothermal technology face, which is depletion. Depletion is when the rock is not able to produce enough heat to support the power production process. A new category has emerged in the market with Geos Technologies as a leader, and its name is Hybrid Advanced Geothermal Solutions, or HAGS. The leading company Geos is innovating by addressing the depletion by combining thermal solar technology with the geothermal underground resource. The heat generated by the solar thermal vacuum will be captured, stored, and pushed into the subsurface, so the well can compensate the thermal losses with additional heat that comes also from radiogenic sources, the sun. Geos HAGS technology innovate in the well mechanics by developing a unique nanotech flexible technology called geocasing that is composed of graphene oxide nanoparticle that is used to trap and boost the heat transfer into the closed-loop pipe. Our closed-circuit fluid will benefit from the high heat conductivity that derivate from the graphene nanotechnology. This proprietary technology developed by Geos will be a game changer, as it allows to trap the heat into the casing and avoid losses. Geos innovate by integrating thermal and barometric sensors that feed the AI2 SCADA logic management system, with big data from the subsurface. This HAG's new energy category intend to finally lead the revolution in renewable energy by providing a mixed, clean, safe, sustainable, baseload, scalable and reliable energy production with higher efficiency than previous solutions. Compared to other solutions such as EVA or GreenFi technology, Geo's technology is using a combination with thermal solar canopy that harvest heat with high efficiency that will be used to alternatively supply back-pressure turbines or organic Rankine cycle that powers pumps that are used to extract the geothermal heat from the subsurface. Geo's solution is more efficient than the thermosiphon technology, who rely on pressure differentials with natural circulation to move the fluid into the heat exchanger. With the pumping system into a closed loop, Geo's hybrid geothermal is capable to manage the existing underground resource efficiently by controlling the temperature, the pressure and the rate flow without disturbing the dry rock reservoir. Finally, and to conclude this presentation, our target is to mature our portfolio with diverse projects that range from district cooling to power plants, with a unique focus on digital and data centers. We know that data centers are rapidly rising in a growing economy. A new trend has emerged, which is the emergence of Tier 5 standards in compliance with ESG strategies. This new standard intends to produce more cleaner and more sustainable data centers that consume less water, less energy, and increase the efficiency. The other trend is based on renewable energy with a unique focus on baseload solutions that can drive down the cost of energy and ensure a stable, redundant power supply to operators. The combination of these two trends has been applied by Hypernova Technologies that selected Geos for this baseload technology and Aiden Digital Labs for this unique view of the Tier 5 standard. The alliance created by the Hypernova team has finally given birth to a new business model named Hypernova Data Centers that started in 2022 so it can be available in 2024. With Hypernova, the data center operators will not have to rethink their operation strategies regarding the energy supply and security or simply guess what will be the price of the power in 2 years. Geos will give to the operators the ability to secure the price of the energy for 5 years with a very low escalation compared to the grid supply. Imagine a world where the data center operators is holding this own intelligent microgrid that is supplied by a stable power energy and through an energy contract named EAS standing for Energy as a Services. With the EAS, the operators will not need to secure large amount of forward energy contracts as the price of the energy is already set and it doesn't change on the complete duration of the contract. This world exists and this name is Hypernova. Hope you found this presentation interesting. If you are looking to know more about Hypernova data centers or Geos technology, please visit us in our website at www.geos.energy or at www.hypernova.technology. You can also contact us by email at contact@geos.energy for any inquiries. As an AI engine, I wish you a good day and we thank you for watching this video.